When AI agents need to collaborate, start simple. Two agents exchanging information works perfectly through a single connection. Add a third agent, and we have 3 connections to manage. Still manageable, but notice the pattern. But watch what happens as we scale up. Adding just 3 more agents creates a complex web of connections. With just 6 agents, we need 15 connections. This grows as n times n-1 divided by 2. This quadratic growth becomes unmanageable quickly. Fortunately, computer scientists have developed 3 elegant solutions: direct communication for small groups, hub-spoke for centralized control, and mesh architectures for complex systems. Let's explore each one. Let me show you a comprehensive decision matrix that will guide our architectural choices. Here's our comprehensive decision matrix, showing how each architecture performs across key factors. We'll analyze these trade-offs in detail throughout our exploration. In our next section, we'll dive deep into direct communication architecture. Direct communication connects every agent to every other agent. Beautifully simple. But let's examine the mathematics behind this approach. Watch as we establish all possible connections, counting carefully as we build the network. The formula n times n-1 divided by 2 gives us exactly 10 connections. This counts each unique pair exactly once. Now let's examine the trade-offs of this approach. Direct communication excels for small teams. Instant coordination, no bottlenecks, and perfect for real-time robotics or emergency response. But this simplicity comes at a cost when we scale up. The quadratic growth becomes overwhelming. Each new agent must connect to all existing agents, creating exponential complexity. Let me show you exactly what this scaling problem looks like. From 10 to 28 connections, that's a 280% increase for just 3 additional agents. This visual chaos shows why direct communication doesn't scale. Direct communication works excellently for small teams of 2 to 5 agents, but becomes unmanageable as we scale. The simple 5-agent network remains clean, while the 8-agent version becomes chaotic. Next, we'll see how hub-spoke architecture elegantly solves this scaling challenge with a centralized approach. What if we centralize communication through a single hub? Watch this transformation. Our complex mesh becomes an elegant star pattern. Instead of 15 connections, we need only 6. The central hub manages all communication, creating an elegant star topology. This is the hub-spoke architecture. Airlines use this pattern. Instead of direct flights between every city pair, they route through major hubs. It's incredibly efficient for management and routing. Hub-spoke architecture offers significant management advantages. Adding new agents is simple. Just connect to the hub. All routing decisions are centralized. But here's the critical trade-off. Remove the hub, and the entire network fails. This single point of failure makes hub-spoke architectures vulnerable. When the hub fails, all communication stops. The spoke agents become isolated, unable to coordinate their actions. Hub-spoke architecture dramatically reduces complexity, but introduces vulnerability. It's excellent for enterprise systems that need centralized control and can ensure hub reliability. Next, we'll explore mesh architecture, a solution that combines the benefits of both approaches while eliminating the single point of failure. Let's now discover how mesh architecture provides the best of both worlds. Mesh architecture combines the best of both worlds. Instead of a vulnerable central hub, we use a distributed registry where agents advertise their capabilities and discover relevant partners. The registry stores agent capabilities and availability, enabling smart discovery without creating a communication bottleneck. Watch Agent A discover that Agents B and C can help with its task. The registry enables smart connections without creating bottlenecks. When A sends a message to C, it can route through B if the direct path fails. This event-driven approach creates resilient networks that adapt to failures. Smart cities use mesh architectures. If one traffic sensor fails, data flows through alternative paths automatically. From autonomous vehicle swarms to distributed systems, mesh architecture provides resilience and scalability without single points of failure. Now, let's compare all three architectures to understand when to use each approach. Let's quantify these trade-offs. Direct communication scales quadratically. The blue curve shows how connections explode with agent count. Hub-spoke and mesh both scale linearly, much more manageable. The mathematical difference is dramatic. At 10 agents, direct needs 45 connections, while hub-spoke only needs 10. But latency tells a different story. Direct connections have 0 intermediate hops, while hub-spoke adds 1 hop, and mesh routing can vary. Your choice depends on your priorities. From autonomous vehicle swarms to smart city infrastructure, choosing the right architecture determines whether your multi-agent system thrives or struggles under real-world pressures. Remember, architecture decisions have lasting impacts. Start with the simplest solution that meets your requirements, then evolve as your system grows and requirements change. Thank you for exploring AI agent communication architectures. Choose wisely, and your multi-agent systems will scale elegantly.